Welcome to this explainer. Today, I'm putting on my senior engineer hat to walk you through something that's absolutely crucial, yet somehow constantly misunderstood in commercial construction. We are looking at the ultimate blueprint for commercial cable tray specification. Too often, this is treated as a minor detail, just a simple line item on a bill of materials. But as we're going to see, getting this right or wrong has massive cascading effects on a project.
So here's our roadmap for today. We're going to look at fatal coordination gaps, the 4 key selection decisions, the zone-by-zone matrix, fill ratios and support rules, and finally, Xinma's manufacturing standards.
All right, part 1, fatal coordination gaps.
Now I want you to really think about this staggering number, greater than 50%. More than half of all late-stage tray rework on commercial projects, it's entirely avoidable. Let me tell you, as a senior engineer, there is nothing more agonizing than watching a crew tear down and reinstall hundreds of feet of tray just because of a clash that we absolutely should have caught in the design phase. That 50% right there, that's lost money, blown deadlines, and compromised systems.
So what's causing all this? It really boils down to 3 notoriously common yet totally preventable coordination gaps. First up, spatial clashes with mechanical systems like HVAC ducts. This usually happens because trades are just working in their own silo drawings. Second, failing to account for overhead clearance. Sure, the tray fits, but technicians literally can't get their hands in there to pull the cables later. And third, ignoring the structural support limits of the building itself. As senior engineers, it is our job to engineer these 3 specific gaps completely out of existence before a single piece of steel is even ordered.
Moving on to part 2, the 4 key tray selection decisions.
You know, a real rookie mistake is treating tray specification as just a single choice. Like, oh, I'll just pick galvanized steel from a catalog and call it a day. No way. The reality is that cable tray selection for a commercial building isn't one decision, it's 4 linked ones. It's a chain, and if just one of those links breaks, the whole system goes down.
You have got to follow this exact sequence. First, establish the load class. Basically, how much physical weight are we actually holding up? Second, assess the environment. Are we in a nice, climate-controlled office or a highly corrosive industrial plant room? Third, determine the cable type. Are we running heavy armored power cables or delicate fiber optics? And fourth, define your maintenance strategy. Think about how often technicians will actually need to get up there to access, add, or remove cables over the entire life cycle of the building. Because if you mess up that exact sequence, your system is inevitably going to suffer from one of 2 project-killing extremes. On one hand, you might overspecify where it's completely unneeded. Think blowing the budget on heavy-duty marine-grade trays for a standard office drop ceiling. Just a total waste. Or even worse, it underperforms where it's actually needed. Imagine using light-duty trays for heavy main risers. That's not just bad design, that is a serious physical hazard and a guaranteed code violation.
Okay, let's jump into part 3, the zone-by-zone selection matrix.
This matrix right here, this needs to be your daily tool. You've got to match specific tray types to their unique environments. Take office ceilings, for example. Space is at a premium, so you usually need lightweight, low-profile trays. But then, look at main risers. Here, you absolutely need heavy-duty ladder trays to handle the massive vertical weight of distribution cables. Data rooms, they need maximum flexibility for constant network upgrades. And life safety routes demand strict, fire-rated enclosures. You can't just buy one type of tray for the whole building, right? You have to engineer it zone by zone.
All right, part 4. Let's talk about fill ratios and support rules. Let's start with power cables. You are strictly restricted to a 40 to 50% maximum fill ratio. Seeing that 55% of empty space is your visual reminder of something critical: heat dissipation. Heavy power cables generate a ton of heat. If you pack that tray to 100%, the cables in the middle are literally going to cook. It degrades the insulation and can cause a catastrophic fire. That empty space isn't just a suggestion, it's a hard engineered requirement. Now, flip over to control and ICT cables, information communication technology. For these, the threshold bumps up just a bit to a strict 60% maximum fill limit. Why? Well, they don't generate the same intense thermal load as power cables, so we can pack them a bit tighter. But listen, we still need that 40% empty space. It prevents us from crushing those delicate data cables at the bottom of the pile, and of course, it leaves room for future network expansions. So I really want you to stop and think about this for a second. What actually happens to system performance and safety when you exceed these precise fill ratios? Well, I'll tell you what happens. Cascading failures. You get intense thermal buildup, signal interference in your data lines, and immediate code violations from the inspectors. And boom, that triggers those massive rework statistics we talked about earlier. Ignoring these fill ratios is basically a guaranteed VIP ticket to the 50% rework club.
And here is another golden rule every senior engineer has burned into their brain. The distance between your supports absolutely governs your overall load class. Honestly, it doesn't matter how incredibly strong your steel tray is. If your supports are spaced too far apart, the whole system is going to sag, buckle, and eventually fail.
Let's look at how this turns into a really practical engineering trick. Say you've got a heavy cable load on a tray supported every 3 meters, and the math shows it's right on the edge of failing. Instead of panicking and buying a massively expensive, custom, extra-thick tray, you just reduce your support span down to 2.4 meters. Just by bringing those supports slightly closer together, you dramatically increase the load capacity of the standard tray. You completely eliminate a complex sizing problem, and honestly, you save your client an absolute fortune.
Finally, let's wrap up with Part 5, Xinma's manufacturing standards. This is where relying on a comprehensive, top-tier manufacturer becomes absolutely critical. Our source material highlights Shanghai Xinma Busway and Cable Tray Company. And what's important to note here isn't just that they make trays, it's that they provide a fully integrated suite of solutions. We're talking standard cable tray systems, high-power busways, critical seismic bracing for earthquake zones, and intelligent cable management. As an engineer, sourcing all of this from one unified ecosystem massively reduces your compatibility risks.
And their specialized solutions scale flawlessly across some really high-stakes environments. We aren't just talking about your standard, everyday office spaces here. These systems are trusted in the intense, high-density environments of data centers, the constant vibration of rail transit, incredibly harsh industrial plants, and massive commercial buildings.
But, most importantly for us specifiers, their products strictly comply with the major international benchmarks, IEC, Xinma, British standards, and GB codes. Listen, when you stamp a drawing, your professional license is on the line. Ensuring the products you specify are legally sound and tested to these rigorous standards, that is exactly what lets a senior engineer sleep soundly at night. So, armed with this sequential blueprint, understanding those fatal coordination gaps, mastering the 4 key decisions, applying your zone matrix, respecting the physics of fill and support, and demanding rigorous manufacturing standards, I want to leave you with one final, vital question to ponder before your very next commercial project begins. Will your next tray specification prevent the 50% rework trap or fall victim to it? The choice in the engineering is now in your hands. Thanks for joining me on this explainer.